Hi, welcome back to the channel. So in this video we will see what are operational parameters. So OPAM parameters, right? So here in the OPAM we will see the parameters. First parameter we will see common mode rejection ratio. What it is? Common mode rejection ratio, right? So where this concept came? This concept came in case of the input modes of op-amp, in especially common mode inputs. In the common mode, what is happening? If the two inputs are same, the output is going to be zero. So that case should not exist, right? So to ignore that, to avoid that input case, so there is a concept called as common mode rejection ratio. This op-amp is having an ability. This op-amp is having an ability to reject. What it is going to do? It is going to reject those common mode signals or unwanted signals which are going to appear at the input, and it is going to amplify the difference between that input and it is going to give you, right? So that is the measure of an op-amp with respect to a differential gain and the common mode gain, or it is an ability to reject the common mode signals. So mathematically how we can write this is CMRR is nothing but it is the ratio between a differential gain to the common mode gain, right? So differential gain is open loop, right? So here we can represent this in terms of 20 log. So it is 20 log of CMRR. It is nothing but AD divided by ACM. So this is what the CMRR definition. So it is decibels, right? So this is the first parameter, very important parameter of the common mode rejection ratio. So in the exam, they may give you differential gain, common mode gain. They ask you to find out the CMRR, or they may be giving you CMRR. They ask you to find out this, right? So the next one, we'll consider the next one, that is input offset voltage. What is that? Input offset voltage. So we should consider all the op-amp characteristics here and we should see in detail. So how to write input offset voltage? It is the presence of small DC voltage which is going to present at the output side. So it is a very small DC voltage present at the output voltage, right? So that is called as input offset voltage, right? So we are represented by VIOS, right? So this is the presence of small DC voltage present at the output section. Remember, even though it is input offset voltage, this is called VIOS. It's a very small voltage, right? Then third one. What is the third one? I can write it as input bias current. What it is? Input bias current. So I will take the help of this only. The current I1 is here, I2 is here. So how we are going to write the current bias current is I bias is I1 plus I2 by 2. So this is the formula. So I can speak about golden rules of the op-amp later about the current. So here input bias current of the op-amp is like this, right? So next one we will consider the fourth one, input resistances. Very important. Input resistance, or we can call it as input impedance, right? So we can write it as R in, right? So input resistance is going to happen for two things: differential input resistance, then common mode input resistance, right? So differential input resistance is like this, common mode input resistance is like this, right? So we should define this resistances. Differential input resistance or common mode input resistance, we have only the one formula. What is the formula for that? It is like this, R is equals to V by I, that is a Ohm's law. So here, if I want to write the differential resistance R in D, so how we can write is, it is with respect to a difference. So we should write here it is delta V with respect to input it is, so it is delta V in D divided by what it is, I. What is that current? Delta I. So in case of I, what is the meaning of I in this case? I bias. What it is? I bias. It is like this. What it is? Differential voltage. What is the differential voltage? V in, right? So that is what here R in D. Similarly, what is the R in with respect to a common mode? Common mode is delta V in common mode divided by delta I bias. Right? So this is the difference. What is that? Differential input resistance and the common mode input resistance. Right? So this is the fourth op-amp parameter. We'll see fifth parameter. What is the fifth parameter? Input offset current. What it is? I will write input offset current. So here we can write it as input offset current is nothing but the current I1 and I2, right? So current I1 and I2. Next, output resistance is there. So we can't give much of the importance for the output resistance, but still we'll write the output uh, resistance. What is the output resistance? Output resistance ideally we have considered it as a 0, right? So output resistance practically also it is very minimal. So we can write it as directly what it is, output resistance. Output resistance is R0. So ideally it is 0, but practically it is around 75 ohm, right? That is what the seventh one we'll see, very important, slew rate. It is about the maximum rate of change of output to the, it is how with respect to the step input it is going to change, right? How to write a step input is, this is the step input. So for this, so how to draw this is from here to here, it is minus Vmax, it is 0, it is plus Vmax, right? So it is minus Vmax. So however the step voltage is increasing, so we call it a slew from here to here, minus to plus. It is called a slew. It is the maximum rate. Maximum means this slew should be very high and this step should be very wide, so that it is going to the rate, maximum rate of change of output voltage, right? So that is called as delta V out. Maximum rate of change of delta out. Rate means delta T. So it is slew. So it is not only this, it is, we can call it as a maximum, right? So we can write it as slew rate. Slew rate as maximum output, that is difference, that is this much with respect to time. What is the time? We can write it as this as delta T, or this time we have seen, right? So this is the slew rate. So these are the op-amp parameters, right? Next, we'll see the op-amp configurations and the golden rules in the next class. Thank you.